Good morning, this is Blas speaking. I want to respond to a question from the FEMAP forum where a FEMAP user posed a problem with meshing small components in a model. Well, I have downloaded the geometry and here we are. Let's answer the problem. Let's try to help. This is the geometry received from the end user. The first problem I see in this type of geometry, I will show everything, is the dimension of the geometry. If I hide the main component, the user report that they want to have a minimum 3 elements in the length. Well, here you are. The geometry is in meters. This is a problem. What I want to do is to convert the geometry from meters to millimeters. This way it will be more easy to handle everything. Working in meters with geometry with a small distance could provoke problems during meshing. This is a question of tolerances. So what I suggest to do is to use command tools, parameters, and well, those parameters you see the tolerance. The automatic tolerance is quite tight, very low. So this is the problem of many meshing errors. So what I suggest is to convert and tools, convert units. It's quite easy. It's simply here you are many factors to multiply not only geometry but also all properties of the model. I have revised the model and I see that also properties are material properties and also element type properties are used in the model, so no problem. We can convert, we can translate everything. Convert units. It's better to use, to load a model, a file, conversion file. I will compare, I will choose, I will move from meters to millimeters. Okay. I will open the file and say OK. Yes, and you are done. Now the geometry is converted, and if I with the distance is 1 inch. Is more reasonable. There was this, also material properties are converted. Everything is converted accordingly. When the model is finished, you can convert to reverse, move to meters and if you want. But the mesh is achieved with accuracy. So first situation, first also I like to move everything, well, modify move by solid, select all. For instance, for this point, this point to 0, 0. You see? Okay. Also, I want to use my own view. Control Q, view, my own parameters. Also, I don't like the default colors of the geometry. I want to change coloring curves and to choose my own. What else? Probably the points also the same. You see, you have points with different colors. This is because you import the geometry probably the native one, not parasolid. Modify color, point, select all, the yellow one. Here we are. This is the core geometry. Also, to help the video recording, I will change the color to black one, to white one. This helps a lot the video recording. Well, also I will get rid of the meshes area to improve the screen space. Well, here we are. The question is how to mesh this geometry. Well, I'm going to show you that I have many components. I will modify colors automatically. This is I use a lot. Select all solid, automatically random to have different colors for every body. Solid body. I can modify color of this one to be more like, well, more, is this air? Well, here we are. Also I can modify transparency, surface, method on solid, and say for instance 65. Well, the question is how to mesh this geometry. Well, from the point of view of text meshing, this is quite easy. I will show you two methods. One, hex meshing, and another method, tetrahedral meshing. It seems that meshing with hexahedral elements is quite complicated. No, not at all, it's very easy. I will show you how easy it is. We can see that the geometry, all the mesh can be created by extrusion with expansion. So the situation. Well, what I will do is to project all the geometry to one plane, for instance, top face of the solid, of the air, mesh a 2D mesh, and then make an extrusion of the geometry, of the mesh in the y-axis. Now I see the geometry. I will check. I will clean up. For instance, if I will clean up everything. For instance, if I see two layers exist. So all this layer. I see geometry. Some geometry is moved to another layer. Well, I will move everything to layer 1. Modify layer, solid, select all, to default layer. Reveal, and here you are. Here you are. The layer, this layer is empty, but surely some properties. Yeah, here you are. I can modify layer, properties, select all, to layer default one. And now I can remove, delete them, this layer. If I rebuild the model, the layer is not recreated because it's empty. Well, also remove groups, everything, and also I will save the model file save as say +1. Okay then. Well, first thing I will do is to see the geometry. Here you are. The user makes some imprints of the geometry each other. Well, we can. What I will do is to show all is to make sure that the geometry is perfect. So I will use the command geometry solid clean up. Geometry is the same. This command solid clean up. Select all and enable advanced cleanup. Say OK. And FEMAP clean all the geometry. And left the geometry perfect for meshing. So reverse. For instance, this one. This body is body number H. Well, no problem. I don't know why the geometry, the redundant geometry is not removed. Probably tool check parameters. Yeah, the merge tolerance is updated. It's correct. Well, doesn't matter. No problem. We have so all. What I will try to do, show you, is how to define, to create the hedge mesh. Well, the first thing is to project everything to the top face. I will choose the top face of this body, this one, the air, to create a 2D mesh and then extrude, make extrusion of the mesh in the y-axis I told before. So I will use command core project normal to which surface or which face, this one, and which curves. Well, I will try for instance command pick around plane. Well, I can select all curves in the plane, but I can select with the mouse all curves. But I want to show you another command is really powerful. Method global plane. She explain and set the point, the plane, okay, a location, the same point, and you see the tolerance is 0. If I hit OK and highlight, you have all the curves. You see all the curves selected. Okay. Okay. All the curves are projected over the top surface, and the top surface is imprinted and splitted. I will repeat command. I will use, because I don't have the curves in the intersection of this body with the air. So which curve to use? Well, simply first we surface this one, and the curves, this one, and also this and this. Okay, and you see the geometry is imprinted. Nothing else. This is enough. All the curves of the geometry are projected over the top surface. Okay, to make things easy, I will modify transparent surface select all 0, and here we are. Now what I want to do is to work the geometry in the top of the surface to make things easy. For instance, I will project I'll make this is to I do this to allow to have correctly a region created to generate mapped mesh. But I see it's quite low. The key, I see that I want to do I want to split also this with this one, this with this, and with this. Okay then. And also I see it's a little, it's not too fast. Well, the key is here. Mesh control, default site. The default site, the element site by default is quite small. Choose for instance a value like 10. And from now in advance, everything will run faster. Splitting will run faster. For instance, you see, it's faster. And for instance, this one, and this one, and this one. Plop. It's quite fast. Also, you can choose but not necessary, but now point to point, and point to edge. Well, okay then, point to edge, or edge to edge, simply. And the rest point to point, the surface. And I think I am done with the rest of surface. Yes, because it's quite easy. Edge to edge, the target, this one, and the source, this one, this one, this one, this one, and this one. And finally, here one, the same, this one, this one, and here, this one, this and this. this is a recommended task to do in order to create mapped regions. You will see the meshing will be immediate. The same here as well. And this one. Okay. Well, here we are. Also, the last thing to do well, you can use the meshing toolbox as well, and using the classical command. I will show you meshing geometry editing point to point. It's faster because no need to hit enter, but the result is the same because I don't have any mesh. Well, done. The geometry is splitted, and I will try to see if I can generate a mapped mesh what base perfectly. So the first thing I will do is to apply to all surface a meshing approach of the type of MapInfo Corner. I will show you. This is my preferred command. It's here, mesh approach. You have here mesh control approach to surface, and we surface this one. You see all the surface in the top. The meshing approach is MapInfo Corner. These approaches are applied automatically when you use the meshing toolbox. Okay. Next, to prescribe the mesh sizing on surface. Which one? The previous one. And the side, well, because we want to have, I will measure. I click in the field, and I hit the keys Control M to measure the curve I want to read, the distance. You see, the distance is, I want to divide by 3. I will hit Control M, Control Insert, and I will copy. I replace the mesh sizing. The rest of the parameters by default. I hit OK, and the geometry is, excuse me, well, here we are. This is the direct. Here we are. We have prescribed the mesh sizing in the geometry. You see 3 elements in the air gap automatically to all the geometry. Seems that the geometry already has mesh sizing from the end user, but what I need to do is simply to split one curve in the direction of the extrusion, and for instance modify break allocation. The curve is 1, and the point, this point, plop, and automatically will define with a split. I repeat, this point, and basically these 2 points are the one required to make the extrusion of the 2D mesh. And what I will do is to define mesh sizing side. I will copy. I will use the same element side in the edge, the same as the surface. And here we are. Here you are. Same elements and so on. Okay then. Well, simply I will mesh 2D mesh. I will mesh the top surface using quad elements. See? Okay. The key here is the property to be in blank, not any property. You don't need to use any property. The measure, quad measure, and map it on, and you are done. Okay. Okay, to mesh with plot only elements, yes. And there you are. If I choose by quad, by shape, and by type, you see, all are quad elements. Okay. You see, the mesh is perfect. Not any mesh quality is perfect. Next step will be to use this mesh. I will split it. Split the geometry. We split it. This one. Okay. And I have materials, 3 materials and 3 properties. No problem, I will choose one property to assign to all geometry. I will show you. The mesh I want to use is the command I want to use is mesh sweep element. Mesh sweep element. This command sweeps elements along a chord, lines to plate, and plates to solids. Okay. Select element to sweep. Method. Well, I can say select all, but method by type. Simply hit 1, and I get all the plot planar elements. The command asks me the chords to select. Please note that the intention you use to select the chords is important. First select this chord, and later this one, and finally this one. Okay. The command asks me one property. Yeah, for instance, air. Okay. I want to delete the original plot planar elements. Okay. And the hex meshing will be immediate. In a few seconds, we'll have all the elements, the hex elements created. And you see, we pass the 2D mesh, plot planar mesh, is converted to brick A-node elements with more than 1,044,000 elements. I will delete everything, the geometry. I want to modify the air. Let's choose another color. Sorry, the material, no, the property, edit color. I will choose this one. Reveal. There you are. And also let's the cap. Palette this one, the board color like this one. Okay then. Well, next step will be, the following step will be to associate the geometry, the mesh with the geometry. Okay then? Actually, all the elements are air. You see, if I hide the property, all elements disappear. Well, what I will do is to associate the mesh to the geometry. How we can do it? Simply modify associativity. In order to select, for instance, if I hide the air, you will see that I will delete from the screen. I will erase from the screen the mesh as well. Not yet, because sorry, not yet, because the command is not issued. The modify associativity automatic command is not issued yet. So first step will be this, to associate which elements? All the elements. Oh, select all command. Anyone. Select all commands. Select all elements. Will be faster than instead to define FEMs in the screen. But okay, let's wait. Well, come on. Okay, here you are. All the elements. Okay then. Select solids to automatically associate. Okay, select all. All solids, the model, select all. All the solids we have here. Okay. And this step is critical. The zero tolerance, 0.02. Well, is what I do is to use the command. Is correct, because if I use the element size, I divide by 20, is more or less the same. The element size divided by 20 is the reasonable tolerance. And also, this step is critical. Detailed associativity summary. If I hit OK, FEMAP will start associating every element and every node to the elements, to the geometry, to the existing geometry. FEMAP will go solid by solid to capturing, to associating the mesh with the geometry. So you can see how easy to use. Now it's a question to wait, because FEMAP only use one processor. Then this task takes some time. I will stop the recording of the video, and when finishing, hopefully 20 minutes or so, I will be back to you. Okay? So I pause the video, and we'll be here in a minute. Hello, back again. Here we are. Well, the process took about less than 15 minutes. So, well, depending on your computer, you can do the job in a faster time, say 10 minutes, for instance. So we have, if I show you the meshes area, I will show you the job that FEMAP did with the mesh. Every solid was associated. You see, the 18 solids were associated with the mesh, with nodes and elements of the mesh. The important is, you see, for every solid, 0 nodes and 0 elements remains in the screen. So every element and every node was associated with the mesh. To demonstrate this to you, I will use the erase command, draw erase command. I will select, for instance, the solid geometry, hit OK, and you will see that the geometry and mesh will disappear. This command is great. Well, what we will have to do, all elements will have, now they have the property air. Well, but we have capacitors. Then all elements we have capacitors, and capacitors were, well, simply I will say the command modify of the elements type. Which elements? For instance, method on solid. Which one? The capacitor, the board, the capacitor board. I will show you. Highlight. There you are. You see? Which property? Capacitor board. Automatically the color change. You see? If I hide the mesh, we have the geometry. We can do the same. We can, for instance, we can hide. I will show you the mesh. We can hide. Which one? The board, and also the air gap. The air gap. Okay. There you are. You see? If I hide the mesh, the elements, there you are, the geometry. The geometry and the mesh is already associated. Don't forget this. But we need to change the property of the elements to assign the property capacitors. So modify, edit, type. Which elements? Well, directly in the screen, a window, or method by solid. Whichever you want. Probably will be faster to use method on solid because you have very low solids instead too much elements, but okay. Done. With property capacitors. Chan. And then there you are. If I hit clear the selection, if I hit the air, if I hide the geometry, there you are. If I show there, but I hide the outside solid, there. You see, the air gap messed with three elements, the capacitors, the board, the base, and everything is fully messed with hexahedral A-node elements. I can rotate the mesh. The model is more than 1 million, 1.4 millions of nodes. Well, this is the way. Okay. Well, I have shown you a method using modify associativity, automatic, and previously using mesh sweep element, how to create hexahedral mesh that initially it seems very complex, but as you see, it's quite easy to do. Okay. Well, sorry for my English. I'm not English speaker. I am Spanish. My language is Spanish. By the way, if you go to the website and you hit, for example, I am located in Bilbao, North Spain, and you look Bilbao, yeah, you are. Nice picture of my city. Okay, really beautiful. We have Guggenheim Museum. It's impressive. Okay. Well, in the next video, I will show you how to mesh the geometry using tetrahedral elements. But you will realize the mesh size will be at another level. Okay then, enjoy. Take care. Bye bye.